welcome to the workshop where we're gonna build a plugin inside Revit, a Revit plugin that's gonna run Stable Diffusion inside Revit. This workshop is brought to you by Archi-Lab, and the team is Conrad Sobon, who couldn't join us today, and myself. I'm a software engineer and computational designer. I also have a background in architecture, and I've been freelancing and working on different stuff, including generative AI, Revit plugins, and web development. So what this workshop is, and maybe some of you just kind of like to define a little bit better what it is about. And there are many areas of work in generative AI, and I put some of them on the slide here, but so this is a very kind of small slice of the pie. So we're kind of like in this area of like applied generative AI, and we're really focusing on creating like a setup for running Stable Diffusion inside Revit. But along the way, we're going to also learn a little bit about web development. For some of you, I think you might be already familiar with that. And also, a little bit of Revit plugin development, but this class is not, strictly, starting a Revit plugin from scratch. I'm going to give you a GitHub repo where you will have like a sort of a skeleton of a Revit plugin built out, and then we're going to kind of complete it together. We're also going to build like a simple Python server, and then we're also going to, we're also going to go a little bit more inside Revit. I could help myself create a Stable Diffusion image about how this is a very small slice of the pie. And so we're going to focus on technical setup demonstration and also explore possibilities how it could be used for other tasks. And some of you might ask, I mean, probably not you, but other people might ask why building a Stable Diffusion inside Revit. So we're addressing curiosity. Some people asked us if it's possible how to do it. For folks who want to use it, it provides seamless integration. You don't have to create images and then put them into another software app in order to generate images. And we're empowering users to take have more control over the generative process. Kind of like making sure that they can do it deliberately in their design workflows. And also bringing AI closer to the user, so you can use it wherever you need it, but also boosting efficiency. Or what this could be applied for beyond like image generation. That's like so it could be enhancing rendering workflows, as you will see. Also bringing generative ideation into Revit directly, but also I think what we're going to show here today will kind of also hopefully help you unlock new opportunities to integrate more than just Stable Diffusion into your kind of Revit workflows. So you can start looking at other models, but also other like language models or agent-based systems with graph algorithms. What we're going to do today, so in the first part, we're going to create, that's like the simplest approach, but also giving you, I think, the most and their easiest access to resources and community. So we're going to build a backend server with Python, and we're going to use that to generate images, and we're going to be making API calls from inside of Revit. And in the second part, we're going to do direct inference with ONX runtime, and I'll explain briefly what it is inside of Revit. You're utilizing a .NET Nugget to do that. In the repo that we're going to share with you, you're also going to have one level kind of like deeper, which is a little bit more low level, like building custom Stable Diffusions pipelines, which is probably most advanced, but gives you the most control. But it's also kind of difficult to set up and requires a little more time, and we won't have time for that in this kind of short workshop. And we're also going to provide you with some kind of like further study material and just kind of curate a list of things that are worth exploring. I like this diagram because it provides some basic terminology that we will be using around during the workshop. So when we talk about a pipeline, it's a kind of like assembly, using simple words, assembly of like different models. So you will have a model that will do the text encoding. You'll have the model that will be actually performing diffusion, scheduler, and decoder. And my ambition is not to explain this to you, but we will be kind of like coming back to it, and especially in those more advanced workflows where you're kind of building your own pipelines, it's worth kind of reading more about it, and in order to understand, because the kind of like plugging and playing it is it's becoming it's becoming easier and more commoditized, but like it still does require some at least like superficial understanding of what's happening in each part of this each part of a pipeline. So just to kind of provide like a visual representation of what we're doing. So we're building this, this lightning represents our external application in Revit. That is, talking to Revit, extracting things from it. We have in the first part, fast API server that's calling, using diffusers to get stable diffusion pipelines. And in the second part, we'll have this ONX runtime directly inside of our external application, in written using C# and running inference in Revit. And I have this diagram. We're not going to cover this, but like it's just to kind of give you a flavor of what this could be built, into. Like you could, and I'm not saying you have to, but like it kind of will give you like foundation to like connect, Python server, and then connect it to other technologies that are available now, and to quite easy to integrate, and then use it with your Revit workflow. And this is something I touched on here, like enabling those more advanced generative AI workflows, or using agent-based systems, and like graph native databases. And with that, we can jump into the actual practical part, doing some things. Does anyone have any questions or comments? And okay, just kind of like to set, like a little bit housekeeping, you can interrupt me whenever you want, or ask questions, or let me know whether I'm going too slow or too fast. Yeah. So are there any comments or questions so far? Okay. If you don't have any questions, what I would ask you to do before we start doing anything, can you please go to this Google Drive? You should have a link, because that's the one provided by, oh, sorry, I can copy. AECtech. But please download these two zipped files. One is file, the other one is a folder. This one is a model. So download them, and then once it's downloaded, make sure that it's unblocked before you unzip it. And then you can extract it. I'm not going to extract it, but you can just extract it here, because I already have it. It might take a while, just a warning. And then the other one is just a Revit sample file. So we can have kind of like the same model as basis, so we have like reproducible conditions. Yeah. How many of you, by the way, is planning to follow along? And who's here just to kind of like, listen in? You can, I don't know, maybe raise your hands or just type in the chat. Okay, Charles. So at least one person. Okay, great. So there's a couple of people. Awesome. Okay, so especially for those of you who are following along, like feel free to interrupt me and stop me whenever you want me to take a break or explain something. So this is, I'm gonna paste the link here in the chat. And I'm also going to like follow along with you. So with the link that I just copy pasted there, open the Git bash. Okay, Conrad has a question. Go ahead, Conrad. And sometimes I might not be able to see it, so just feel free to unmute yourself whenever you want to say something. Or maybe it was just, okay, to signal that he's following along. Okay, so open Git bash. Git bash is a command line tool that, you know, lets you interact with Git inside of Windows. And so when you open it, you should see something like this. And you might find, so like for example, if I think if I open it, let me open it from scratch so that we can have some kind of reproducibility. Okay, if I open it, I'll be here, which is a root folder. So I'm going to where I keep my repos is in the folder called source and then repos. And I think when you download Git bash or Visual Studio, I think it's created automatically. So you might already have it, but if not, if you want to create a folder, you can either create, you know, go to a location where you want to put it, and then you know, call it a repo or workshop, and then in that folder, you're going to type git clone, and then paste the address that I pasted in the chat, and you're going to hit enter. Yeah, I already did that, but that's okay because I have. So CDs, it takes you to a directory where you want to go. So I'm just going to go to another one that doesn't have the folder that I want to actually create. I'm going to paste it and try again. And now it's cloning, and it should have cloned what I wanted to. And when I click ls, it's going to list everything that's in there. And so if that's what it returns, then you're in luck.
Would it be possible to make the font a little bit larger?
Yeah, let me try doing this. Like this. Okay, we're gonna do one more thing. We're gonna make sure that we have all branches for later. Okay, first we have to navigate to that repository that we just cloned. So we're gonna type cd, and then as you're typing, you can hit tab and it should autocomplete for you. And when you click enter, it's gonna take you there. So now you will have all the contents of your repository here. And I'm gonna be in this repository, and now I can fetch. Yeah, so, and it even kind of corrects me if I make a mistake. Yeah, so I'm gonna list all the branches by typing git branch r. And I'm going to go to main branch by typing checkout main. Okay, I'm already there, great. And now, just to kind of like step back a little bit, maybe let's talk about the content of this repository. So we also kind of want you to use this as a reference for your future explorations. So this repository is like documented pretty accurately, and you have steps how to get started. So pretty much anything that I'm going to be doing here is already here. There might be some things that are not here, But even if you were not here and you had this repo, technically you can just reproduce everything we're covering in this workshop on your own, which I think, is pretty cool. And also some kind of like notes on like development or like kind of problems that we might have encountered, as well as like setup of diffusion models. And we're probably going to add some things after the workshop, so you can even like start or kind of like come back to this repo if you want to. It has several branches that already have everything that we're going to cover. So it has step 1, step 2, and step 3. I would ask you to stay on, if you're following along, stay on this, on the main branch, and then we're going to kind of cover all of it together. The way it's organized, it's not a single C# solution, so it has several mini applications, or kind of like some of it is not even an app, it's more a utility. So that could help you, let's say, do the things that are kind of required to do some of the more advanced workflows in this workshop, but also just to make sure that, sometimes just to help you out with like simple things like verifying your CUDA installation. But the main things that we are interested in right now is Revit plugin and model server, and we're going to take a look at it a little bit later. And we're going to start with the model server, which right now is empty, but we're going to start building a server here. And as I said, you have getting started here, and then also I'm going to add useful links that you should also have some of them here. Like, for example, if maybe you're lost with like the C# Revit plugin development, I would recommend watching one of these classes or both of them that Conrad made in the past during the AECtech, and because the plugin that we built here kind of follows all the design patterns that he's usually applying when he's building those things. And yeah, that's pretty much it. Is there a question? I think I saw someone raising a hand. Oh, okay, cool. Good. So now we're back here, and we can, so this folder structure or the directory structure that we just saw on GitHub, we now have it on, after cloning it, we have it on our computer. So when you type explorer.exe and then space and dot, it opens the directory you're in at the moment of the executing this command. So when you open it, it opens in Explorer, and then this is what you have here. So you have the Git folder that's responsible, where the Git keeps all the information and metadata about the Git repository that we just cloned, and also all the other folders that were that we saw and discussed that were online. Just to kind of verify that the Revit plugin was installed properly, before we start developing, we're going to kind of verify a couple things. I think first thing we're going to verify is that the Revit skeleton that I built works, and we're going to do it by opening Visual Studio 2022 and going to the directory where you cloned the repo. To Revit plugin, clicking at this file, Revit plugin solution, and then hitting open. It should open like this. So nothing is actually opened here, but if you go to the Solution Explorer and then click on the app command or any other class, you will be able to see it. And then can someone verify for me that they were able to do this, and also that this Revit 2025 is highlighted and is set as startup project?
It is for me.
It is? Okay, great. When you right click on this project, hit properties, and then go to debugging, do you have this profile there? So you go to properties, then debug, and then click open debug launch profiles UI. Do you have this executable? Probably not.
I do.
You do? Okay, cool. That's awesome. So now you can hit build, rebuild, or just build. And after it builds successfully, did it build successfully, by the way? So if you type cd and then ls, are these the folders that you can see? But you could actually do this, I think. So you can copy this. I'm just gonna format it here, which obviously didn't do the trick. Okay, yeah, so type in cd, start typing desktop and then tab, and it should take you to desktop. And then Haley and whoever has this like the same error, type in mkdir and let's call it workshop AECtech, workshop / AECtech. And then if you want to clear it, you can clear, and then it's going to clear the screen. CD, start typing workshop and navigate there and repeat the command. By the way, if you hit arrow up, you should be able to go back in the history of your commands. So you can go all the way up to git clone, and then you can hit enter and then repeat the steps there. So once it's downloaded, go to that directory in Visual Studio and build it and see if you're getting the same or a different error. Don't forget to open Visual Studio as an administrator. So after you built it, you can, and maybe I clicked it too fast, but you can click this play button and that will start debugging. So what it essentially will do, it will open Revit. And because Revit is like the application that we're building is attached to an external application that's Revit. And so it opens it while it's debugging, and then and this all will be, because it's kind of like, it's all like the Conrad covered in his previous workshops. That's why I'm not explaining it exactly, but Revit accesses the DLL, and now we have the plugin. So if you go on the tab to the Stable Diffusion MC, and kind of like for a better view, you can, so this is the skeleton of the app. You click on this button here called Stable Diffusion, and you should have this. And I'm pretty sure that if you try clicking on generate, it's just gonna break. Yeah, because it's designed to throw a new not implemented exception. It's just gonna kind of kill the app in this because we're not doing anything with it. So Revit can't access it. Revit can exit it, and we're not catching this. So that's what happened. But we're gonna build this out in the second part of the workshop, so we can essentially close the Visual Studio. You don't have to close it, but I mean you can also close it if you want for now, because we're gonna start with the Python server. By the way, just as a kind of quick intro or like reminder what we're going to be using here, or like maybe kind of like just going through the tools that we're going to be using for folks who might not be familiar with some of them. We're going to be using Visual Studio. That will be our main IDE for Revit plugin development. And we're going to use Visual Studio Code, which is an open source platform, and it's faster, and I prefer it building Python applications. And we're going to be using Git Bash that we've already been kind of using so far. Does anyone have any other questions or problems, or can we just move forward? Okay, let's go. So I'm going to go to the okay, I'm going to go to the repository that I created, and we're gonna start. Even before we start building the server, we're gonna do one quick thing. We're gonna verify our CUDA installation. So we're gonna go to this folder called CUDA Utilities. And here, in order to be able to run, okay, I'm going to close my Visual Studio Code. And in order to open it here in the directory where you are, I'm actually going to go back because I want to open it at the root of this repository. So I went back to the folder where the entire workshop, all the folders are located. And in this folder, I'm going to type code, space, and dot. And if you installed the Visual Studio Code, it will open an instance of it inside of that folder. And here, because I want to be specific, and so I'm going to go to that folder because it's, as I said, it's a little bit of its own application. I'm going to navigate to CUDA Utilities, and here I'm going to, if I in order to execute this Python file that I have here, I will I need some libraries, and I pretty much only need Torch, but Torch also requires other ones, and I have everything that I need here. So I could just install whatever I have here, but and that's what I'm going to do. And but please do one thing, because I think sometimes it can create an error. So for all those Torch Audio, and Torch Vision, delete this part after with plus CU124. And I did it for all three of them. And then hit save or Control S. And then what we're going to do here, first, we're going to create a virtual environment so we can have an isolated environment that we can run this file in. And we're going to do it using a command. We're going to Python with module called VNV, and we're going to specify the folder where this environment should be created. And we're going to click, we're going to hit enter, and it will take a couple seconds. And after it's done, the virtual environment will be created, and now we have to activate it. And we're going to activate it by typing source, the name of the folder, subfolder, and the script. So source VNV script activate. Okay, it has to be script activate. And now when you see this VNV above, the identifier of where you are, then we're good to go. And so now we're in this isolated virtual environment for Python, and we're gonna install all of our required libraries, Python libraries, by typing pip install with R flag. That means recursive, and we're gonna type the name of the file where we saved all of our libraries, and we're gonna hit enter, and it's going to gather all those libraries and install them, packages. It might take a while, so I'm maybe a couple minutes. So I can, if there are any questions, I can. Okay, Sergey is already on it.
Patryk, can Can I have you run through that bash command real quick? I got lost at that point.
Awesome.
So
Yeah.
like you had started the virtual environment
Totally.
and then
Yeah.
I got lost at that point.
Awesome. By the way, you can copy all the commands from here. If you go to that GitHub, you should have them all here. So obviously this one is specific, right? So you have to modify your directory here, but you're already in, and you're not in model server, you're supposed to be inside of CUDA utilities right now, right? Are you in that folder? And if you are,
no, I am not, but I can get into it.
Yeah, so get into it using CD, and then you will have the path here, and that means that you're in it inside of that folder. And once you're there, let me know.
Okay, I am now inside of the utilities.
Awesome. So now you can, instead of those utilities, you can create your own environment, and using the command Python with the flag M means it means module, I think, and the module is called VNV, and the folder is also, you can call it anything you want, but it's kind of like customary to call it VNV unless you have your own system and you want to be more specific. But then you have to kind of remember to use the same name in every other command. So Python module flag M, so -m VNV enter. It should take a couple seconds, and then activate this environment using this command source, and then pip install recursively every single package that's in requirements txt.
Awesome,
And
thank you.
so it took kind of 2 to 3 minutes, but now it says successfully installed all these packages. And by the way, if sometimes even by mistake, or maybe you wanted some of the packages you might want to have installed globally. So if you, for example, if this VNV is not here, it means you're kind of like working globally, and then it would install everything inside this kind of global environment for your entire, for the user or for the computer, right? Depending how you have it kind of configured. So you especially wanted to avoid it when you're kind of like, because it's cleaner, and you have different projects with different requirements, right? So that's why you need this separated environment. And now just to verify our CUDA installation, we can do Python and then run the main py file. So what it will do, that's interesting.
I just got the same thing, and I certainly have a CUDA GPU.
Okay, cool. I wonder why.
Is the PyTorch version, because I'm pretty sure there's a CPU version and GPU version.
Yeah, there is. But we did install, I think, GPU, but yeah, maybe that's the problem here. But for previously, sorry, I'm gonna try it again. Okay, so what we're gonna do actually is actually go do this instead of. So what I'm gonna do actually, I mean, it's okay that happened. So I think this pointer is somehow interpreted incorrectly when you're installing in this way, like from requirements, because it can't find this. So it kind of like writes it down like this. I don't know if it's internal bug or I'm doing something wrong, but what we're gonna do is like a quick way of deleting the environment. First, I'm gonna type deactivate. And then I'm going to remove that folder. So I'm going to do rm rf vnv, and it essentially will delete that environment. And then once it's gone, I'm just going to repeat the setup. So I'm going to do this. And I think don't worry that it's like we're kind of debugging it, because I think it's the most annoying part of this setup. But I think everything after that goes kind of smoothly, and I think probably it's the most useful thing of this workshop, like debugging errors that can happen setting this up. Okay, so and then activate, and then what we're gonna do, we're going to use this command that we have here. And yeah, some of you probably noticed the Control C doesn't work in Git Bash. At least it doesn't work on my computer, but you can use, I think, Shift and Insert for copying and for pasting. For pasting, I think it's something else. Yeah, Shift and Insert.
Right click.
Yeah. So I just use right click is the easiest one here. And for people who are familiar developing on Linux, you can also use WSL. And I personally use that most of the time. And then the syntax is a little bit different. So I'm used to the other syntax. We're using Git Bash for Python development just so because we're already using Visual Studio Code, Visual Studio, and now Git Bash. So I was trying to simplify things. So that's why I'm using it with I'm building in Windows. But actually, probably if you might want to investigate it, and maybe if you're comfortable moving to, or maybe you already are using it in your work, day-to-day work, move to Linux, because a lot of the models are actually, or like functions or utilities are developed on Linux, so some of them can work slightly better in Linux, and maybe Sergey can refute or confirm that, but I think that's true. Yeah. Yeah, so this should install the correct version, and now we should be able to verify the CUDA. Okay, so that's installed, and let's try our luck again. Okay, good. That's working. Okay, a good comment, Sergey. Yeah. So, is anyone seeing success?
It's still installing the dependencies, but
It should also give you so I think if you don't have like GPU compatible with CUDA, it might fail. I'm not sure if that's true, but I think that might be the case. But it will also tell you what's available to you. And I said, I wrote in an email that you should have at least 16, but I only have 12, and it does work. So if you have at least 12, you should be able to create interesting images in this, but obviously the more the better. Okay, how's it going, everyone?
I'm attempting to get Torch.
It's working.
Oh, amazing. Great. So on my end, I'm going to now deactivate this environment, and it is a little bit redundant, and I couldn't, utilities are a little small. If I were just building it for myself, I would have this folder inside of a server probably. And what I mean redundant is because right now we're going to go to the model server where we're going to build the rest of, where we're going to spend, a significant portion of our time actually building that server. And so I'm going to navigate back to our Git repository root directory, and from there I'm going to go to model server and I'm going to set up environment there. So make sure that you deactivated the old environment. And are you still waiting, or can I continue, by the way, folks? Nathan, is everything okay?
I'm still trying to get it all set up. You can keep going though, you're fine.
To clarify,
Yeah.
the install path for the Torch and Torch Vision, that was the one on the doc that you had sent out, correct?
Yeah, I think so. Okay, let me go to the doc. Which one do you mean?
Yep,
Here,
right
right?
there.
Yeah.
Yep, and that path below.
That's the path, and the same path is on the GitHub site.
Awesome.
That's where I copied it from. But you can, so actually, if you click on this link, because you might have different preferences here. If you go to this link, there is like this little funky tool that PyTorch created. So you pick your build, your operating system, and we're building in Windows now, and then the package, what language you're developing, and then the version. So my CUDA actually is 12.6, but they don't have it here. So I actually installed 12.4 and it works. So you don't have to, but that's how you kind of obtain the link. And then you copy this link from here. And I don't use pip3. So just delete pip3 because I don't think it would work on my system, but it might work on, depending like what kind of Python and pip you have.
For Taro's question, this is the thing I commented on in the Slack channel. You can't be on Python 3.13 and download Torch, is what I found earlier today.
Okay, yeah.
So you may need to be on Python 3.12.
I think that's what I'm running into.
Okay. Are you going to be able to downgrade?
Yeah, I can get it figured out and I can follow your document.
Okay. So because this part is, I'm just gonna continue with this one because it's actually repeating what we already did. So we're gonna do again create the virtual environment inside of the model server folder where we're gonna build our small server application. So we're gonna type Python module VNV and VNV. We're gonna let it set it up for us, and then we're going to activate it by typing source VNV scripts activate, hitting enter. And right now, what I'm going to do, I'm just going to do the same thing. I'm going to install Torch. As we're waiting for this to install, a couple of notes, and I'll put it on the GitHub too, but and starting from, I think this, because after this workshop, you should be comfortable using this as a reference. So a lot of the code you can find on a Hugging Face diffuser docs. And there's this one that I found really useful, especially in the context of this workshop. is, I'm actually, I can also copy paste it in the chat. Is this one here where they kind of present different pipelines and how can they be used for, you know, so kind of like from image to image, how to control the weights, I mean, not weights, like guidance scale, strength of the algorithm. So for example, and you can see the results and understand them intuitively by kind of like looking what parameters or like what values they use and how it affected the image. For other pipeline, you know, how guidance scale affected the image. And okay, just to maybe go over strength is, you know, as they say, one of the most important parameters. And it kind of, what it does to the image is like it either lets the model be a little more creative, and the higher it is, the more creative the model will be. The lower it is, the stronger it will try to follow the input image. For guidance scale, it's how strongly it will follow the prompt. So the higher it is, the more it's going to try to build the generated image will try to follow the prompt more. And then the one that we'll be actually working with today is one of the ControlNet versions, because I think for the purpose of this workshop, I kind of found it the most useful for working with Revit. So we're going to be using those kind of sketch-like images, which are generating using Kenny Edge recognition. And so what we're doing here is we take as an input a Revit screenshot, which I actually have here. Like this. I just invert the colors because it already has edges, so we don't have to apply any algorithms here. But that's what it would be kind of, you know, categorized as this Kenny edges image, and then we feed it here in order to create something that can either, you know, be enhanced or whatever. But why I'm also like talking about this is like you can get a lot of interesting ideas from this particular article, how to also stack those pipelines. So for example, you could generate some starting image and then put it into another pipeline in order to kind of creatively, you know, modify it. Yeah, and another important repository or website is, you know, Hugging Face, finding a model that you want to work with, and then reading about this model. And usually they also have samples here. They have a little instructions how to use them and how to create and even integrate them, and also links to more information and more details. So what we're going to do here, we're going to install now, continue kind of like setting up our environment. So what I'm actually going to do now is, because I know that this model requires these libraries, so I'm just going to copy it from here. I'm going to I don't know why it doesn't want to copy. Okay, now I pasted everything. I'm going to install diffusers first. It's also probably this is the second most time consuming library to install. Okay, and other libraries that we're going to need in order to build our server. And then another useful for what we're doing is the documentation regarding setting up a server using Fast API. It's a Python micro framework for building API servers. So what we're going to do here, we're just gonna install Fast API. So I'm gonna copy it from here. It's not anywhere. So it's not in any of the documents that I shared, so I'm gonna put it here. And after we have this, we should be good to go.
I got my PyTorch installed. What were you getting the diffusers? Was that next?
Yeah, okay. Let me paste it all in the chat, all the comments that you have to run now. Okay, cool. I'm gonna paste it in that document. Do you still have access to it?
Yeah, I think so.
Okay, cool.
Yeah, I see it.
Okay. So first diffusers, your torch is installed, right? And it's working.
Mm-hmm.
And you're in the model server, right? Folder.
Okay, I can get to it. Yeah.
You need to go there, deactivate your current environment that you used for verifying CUDA. Go to the server, create new environment. So pretty much repeat the same steps and activate it.
Diffusers are installing. Sweet, thank you.
No problem.
And you did the rest of that in the same environment, right?
Yeah, and everything else is going to be in the same environment. This is the last environment that we create, I promise. Okay. So I'm going to slowly start building the server, kind of waiting for you to get properly set up. But so what we're going to do now, we're going to go to our code application that you opened, hopefully in the root folder of the Git repository. So you should see something like that. You will see the name of the Git repo here. And when you expand it, you will see folders and README files, everything that's in there. Wade, do you see that? Are you there, Wade?
Yeah, I'm with you.
Okay, awesome.
I'm sweating, but I'm with you.
No worries. I know it's a bit of a crash course in a lot of kind of like pieces that come together, but I think that after the workshop, you can kind of, go back to your work and kind of like explore this and like kind of maybe, read the documentation and start building it. But I think the most important skill is that you're going to understand what's in the repo and you're going to be able to like play with it, I think. So don't worry if you're like sweating, because I think it's a lot, and it's like, we have like two kind of development editors or like coding editors, one the big Visual Studio, then this, and then we have and on top of that Stable Diffusion, or like all those kind of like Gen AI models. They're also and it's not that they're kind of like super difficult, but they're kind of painful to set up, right? And a lot of things can go wrong technically, but sometimes you don't even know what went wrong, you know, because they're kind of like sensitive. But anyways, we're here, so I'm good.
It's
I'm glad that,
it's a good
yeah.
sweat. So
Yeah, exactly. So yeah, so in the model server, so you can expand it and then right click on the folder and add new file and then name it main.py. And I'm just going to demonstrate because I'm going to create another one. I'm not going to touch it yet, but I'm going to create another Python file where I'm going to save my machine learning algorithms or like functions. So it's got, I want to have two files here. One is going to be main.python, so main.py, where I'm going to save my, where I'm going to build my server. So that's going to build you know, this kind of layer that's going to interact with Revit. So you know, it's an application that's going to be receiving kind of messages from my Revit application and doing something with it. And in machine learning or ML.py file, I'm just going to create functions that connect to the machine learning layer, all the models. Yeah, here. And then here, what we're going to do is, so first we're going to import the thing that we need in order to set up this. And we're going to, first, it's just going to be like super simple. So like that's why we also chose Fast API, because Fast API is very intuitive to learn and also very quick, and also has a lot of features that make it fast and easy to develop. So it's not only kind of like on the intuitive side of like building things, you know, the web development, but also it has a lot of good stuff that helps you help your application be faster and more efficient.
So if it's not if it's not recognizing Fast API, I got everything installed just now, but if it's not recognizing Fast API, like it's the IntelliSense isn't grabbing it.
Yeah, sometimes IntelliSense can be tricky. So okay, so you have to also run this pip install this, right?
Yeah,
After
I
it's
got
done,
that one.
yeah, you might if you really want IntelliSense to work, you might want to restart the code.
Okay.
But I think when I opened, I didn't have Fast API installed, but I might have it somewhere else, like in a global pip. So, but sometimes it does tell me that it doesn't recognize it, but it still works. So let's first let's kind of build this kind of like the basic application, and then once we run it, you're gonna know whether it's actually problematic or no. Okay, and just so you know, instead of just typing the code, I'm going to tell you so you can go back later and find it yourself. So pretty much, this is the code that I'm going to type as a starter. And so this is how simple this is. So in order to like build your server, and you know, after this workshop, you're going to know what to do with it, because you know, maybe you can ask like, why do I need a server? But anyways, so this is all the code that you need. So you can actually copy it from here. And from here, I can also post it in the chat. And go there, copy it from here, and that would be like your first step, and then you can start learning about it. And you'll see what you'll see in a moment how many things you actually are getting kind of like for free. That's because the way the Fast API is built. So the Fast API, it's a class. So we're importing from Fast API module, we're importing a class that actually builds the application for us. And the minimum that it kind of needs to function, at least as far as I know, is we're adding this. So this is a decorator. It's a function that, and if you if you want to kind of go deeper, you can read about it later, or we can talk about it maybe later. But you can actually define your own decorators. But it's kind of like a way of adding functions to other functions that modify their behavior without kind of like the kind of like I don't know, making your code more modular. So this is similar to what you would also have like in Flask. But you add a decorator that actually defines a route for you that another application can actually call in order to receive a response. So like kind of like when you're on internet and when you go to like a home page, the server, like your web browser calls a server, and and it kind of like connects you to that server and sends a response after a response to your request. So this is what we're kind of creating here. And like, don't worry if it's like again, like if it's a little bit complicated, but right now, because it's not kind of crucial, and I think it will be easier to understand when I show you what it does. Okay, so once you kind of either type this here or copy paste it here, usually you can if when you're developing, and so that's one of those things that you kind of like so sometimes they work differently on Windows. It's like usually when I'm developing on WSL, I would just type now fast API dev, and it starts the server for you, and you can just and it also serves it and you can access it. But it doesn't work for some reason here. I didn't want to spend time investigating why not. And okay, I think my my git bash is lagging, so I guess I'll have to just type it. Okay, so I'm essentially similar to what I was calling those commands like Python. I'm right now calling unicorn, specifying where my app is, and then I'm adding a flag reload so that it reloads whenever I make changes. It's very useful for development. So it's going to reload as soon as it detects a change in one of the files that we just edited. And when you hit enter, it will start kind of, so the server is running now, and we'll start kind of like in the terminal here. It will start outputting messages. So and you kind of know what's happening behind. So it's running, and then you can access it here. It's being served in this address. And it started reloader, and it started the server process, and it's waiting for the application to start up, and now its application is complete. So if you go to your browser, paste this address and hit enter, the server, the application that you just created, gonna send a response back to you. And in this instance, it's a really simple response, and it's just hello world. That's what we built just now with those 10 lines of code. Do you have any questions?
So I got a error loading ASGI app, attribute app, not found in module.
Can you, okay. Do you have app here like that? Did you, what's your?
Yep, I can share my screen.
Yeah, please share your screen.
Maybe.
I have to
it
stop.
says the host is not allowing.
Yeah, go ahead. I think now you should be able to. Maybe you can't kick me out, but maybe now you can. Yeah.
Okay, is it sharing?
Yeah. Okay, your.
Sorry, I lost you there for a second.
Me? No, I wasn't saying
me?
anything. Yeah, I can hear you. Sorry, I'm just reading. Okay.
Also, just to roll out simple stuff, have you saved the main.py? Because I see that there's like
it's not saved. Yeah.
Okay, sorry, my headset died at the exact moment I shared my screen. So save, that's the debug.
Well, let's start there.
Yep.
Yeah, it's working now.
Great.
There we go.
Awesome.
Thanks, Sergey.
Is it plugged in? Have you tried restarting this? Have you saved?
Have you saved? So yeah, wait, if you go now to, let me show, okay. If you go now to, yeah.
Just to let you know, yeah, the IntelliSense not working, but everything is working. So.
Yeah. Same thing for weight, I think. Yeah. So now, and then if you go there, you're going to get the response. But the really cool thing about Fast API is that when you type /docs, you're going to get automated docs. And you can try it out and then execute, and it's going to give you a bunch of information and how to interact with your server. So now we kind of built a right now simple API server that you can use for really cool applications, and we're gonna now explore how to use it with Stable Diffusion in order to call it in Revit. Is everyone ready now to move forward? Awesome. Okay, cool. So in similar way, we kind of defined like our root here. So yeah, maybe kind of to step back. So what a root is like, okay, the app is being served on this address, and the root is whatever comes after it, right? So with our decorator, we define this root. So every time you go here, this is what the response that it's going to give you, right? So right now what we want to do, actually, we want to start using it to generate some images using Stable Diffusion. And so we need we want another root. We could obviously delete this one, but we're just going to keep it as an example here. But what we want to do, let's call it, and by the way, we're doing it in kind of like a messy or hacky way because it's a workshop, but there are actually standards how to build those roots. If you're kind of building a serious API for your organizations, you want to maybe read a little bit about it and follow those standards. One of them is called RESTful API design, and depending, what you're kind of, so it's already suggesting here something that would comply with it. So you have items and then items ID. But what I'm going to do is I'm just going to type text to image, because that's what we're going to be doing with Stable Diffusion. And then we're going to define another function. We're going to call it, you could say text to image, or we could say generate, whatever. Let's call it text to image. And yeah, it's a good starter because we have nothing else here. So let's see what happens when we just type text to image. And you probably already know. So if I have this basic address and then type text to image here, now the message that is responding should be text to image. So right now, what we want to do is pretty much here, we want to do, okay, this is not C#, so we want to do something interesting. So we want to call a function that will generate an image from text. So in order to do that, we need to actually import some of the libraries that we installed previously. And maybe let's put it for now in this one file. I have this machine learning, and I'm going to put kind of like separate my code that kind of handles API stuff and machine learning in separate files. But just to show you that you actually don't have to do it, it's good practice. But in order to organize your code in like in a modular and clean way, but you don't have to. And kind of like using the resources that that you're gonna use later. Let's see what we have here. So where we are now is this Hugging Face model card of this extra large base model. And here we already installed all the things that we need. So this looks like, to me, like we can use this snippet to create something simple. So let's try it out. I'm gonna paste it here and organize it a little bit. So what I want to do, I'm gonna paste it here, and I probably want at least some of it to be wrapped in a function that I can then call here and return. But I could probably just do something really hacky, like this, and see if it's working. And then add it here, and what am I going to do now? I could either save it or write it to a memory stream, which is a little bit more efficient. I can save it, and yeah, GitHub Copilot is writing everything for me. And instead of returning this message, I could now return streaming, but I think streaming response, but I think I have to import it first. And now I can media type image PNG. I think this might work. Okay, let's see what we get. And now restarting will probably take a little bit longer because it will be loading the pipeline. So after I saved it, see, it's kind of waiting. And now it's loading the components of the pipeline. It will take a while. And now it will try to prepare the documentation, and it looks like it started successfully. So let's go to our docs. And we're going to go to the documentation now because it's a little bit, it's easier to interact with this. And we're not asking any input. So right now it's going to just use this prompt to generate something. So let's see if it's working. I'm going to click on execute. Now I'm going to see what's happening here. Okay, the server received the response, and now it's generating the image. It looks like it's working because I'm getting this response. It's logging, or it's printing this to the server console that it's progress. And I know it's gonna try. It has 50 inference steps, and it's right now it's moving pretty fast. So that's pretty good. I'm gonna, but now we're gonna add a bunch of stuff so we can actually control the generation, because right now we would have to change the code. So we're gonna parameterize this function so that we can actually send some information from outside of our application. Okay, so now we have an error. So I probably, yeah, I did not import something. I forgot about an import.
IO.
IO, yeah. I think one other thing that I'm going to do, I'm just going to limit, and it's giving me this. I'm going to limit it to 15. That's just so we're not waiting this long. So the images will be a little bit less exciting, but so yeah, so this is an old error. The pipeline is loading again. Application started, and let's give it another try. Okay, it looks successful, but let's see. Yeah, okay. So now we have this like really simple setup, so now we have the server, and what we have here, we can, we can technically even use it as, because, we're going to see how when we parameterize the function, how we can actually put input. We can use it as kind of like our own mini Stable Diffusion app. and have like full control over what we want to be changing, adding new pipelines. So this is kind of like the simplest way of like getting access to it, and in like a programmatic way with a bit of like interface. But what we're actually going to use it is like we're going to make calls, because it doesn't have to. Okay, so what's happening here actually, and it's actually visible here. It's accepting those calls from it could from outside for any other application to this address, and then now you can talk to the server. So we're going to define how the server is what responses is accepting, and what request is expecting. Accepting, and what response it is returning. And then we're going to integrate it with our Revit application. Okay, cool. Are there any questions so far? Was anyone able to get the image?
I need to copy the stuff inside of your function, but otherwise it looks like it's working. Was there a particular place where you had pulled that everything underneath async def text to image?
Where did I take it from?
Yeah.
Yeah, totally. Everything, it comes from here, actually.
All right, cool.
But I can actually put it in the chat, the whole function, if you want. Also, if you copied and it looks ugly, you can right-click in the document and, okay, you can do it with Python, right? Okay, Python won't do it, but JavaScript would.
Just out of curiosity, I usually use Flask, so I'm not as familiar with Fast API.
Yeah.
Do you just get documentation for free?
Yes.
Yeah. That's awesome.
Yeah, it is really awesome. So like, like with, I don't know what, 5 lines of code, you have, you have this, and you can, it actually is very, and I don't know if you'll see also that that's when I think, like, especially in the context of Fast API, it's worth using types in Python, which is not a super popular thing, but especially if you're working on a team, super useful and like makes debugging and collaboration faster. But when we're gonna kind of like start adding types here, it's even better, because then you have like documentation that even tells you it's like it's ready, right? it's you don't have to do anything yet.
It's really sweet.
Okay.
So
one thing, yeah, go ahead.
I'm still getting I'm getting a torch not compiled with CUDA enabled. It may just be, I don't know. I'm working on a laptop.
With what? With what?
When I just put your code in there, for example, and I'm getting a torch not compiled with CUDA enabled. And my git bash as it from the server, feedback from the server.
Okay. Do you want to share your screen?
Yeah, I can do that.
Oh, I have to stop. Wait, 1 sec.
Right here.
I can't see. Still, you're not sharing, I don't think.
Oh, is it not? Oh, there.
Yeah, now it's sharing.
There you
go. Okay. Okay.
And I just tried to run the install command again just to be sure, but
CUDA, the CUDA install command, you mean?
Mm-hmm.
What output did you get when we were doing the CUDA installation validation? What did it say? Did it say that it was successful?
I'd have to go back and look.
You know what? Go all the way down and actually hit Control C to kill the server.
Mm-hmm.
Yeah, that's, by the way, that's how you stop a server or like a process when you're in the terminal. You can do it with Control-C. Probably that's one of the reasons why Git bash doesn't use it for. Are you inside and did you hit Control-C?
I thought I did. I'm hitting it, but it's not.
Okay. What if you try typing like, I don't know, quit and enter? Can you do anything there? Or Q and enter?
Nope, not doing anything.
It might have blocked out.
Yeah, I guess so. I was gonna kill it, get back into it.
Yeah, maybe kill it and like restart it. Ideally restart your computer so it kills like all the processes that are
Okay.
running. So because sometimes it can like or be orphaned and like it would like interfere. So maybe restart your computer.
Okay.
And then when you restart it, we can troubleshoot it again. Okay.
Okay.
Yeah.
Sounds good.
No worries. Okay, so before we start building this out, let's actually move out the things that we, like the machine learning functions that we're calling to a separate file. The file that we prepared here. So, okay, what we're gonna do here, I'm gonna slowly start removing actually anything that doesn't that doesn't handle actually the server. I'm going to be removing anything that's not server functionality outside from here. So we have a cleaner file just because the file is going to get bigger and what we're going to do, yeah, this is good. Just gonna cut it out, put it here. But here I'm just going to images equals generate image text. And this is a function that we're gonna write, we're gonna wrap our pipe, our image generation part of it in here. So what we're gonna do here, we're just gonna import it. But first we can also define it here. Okay. So we're going to go define generate image from text. And define, okay, the prompt is here. Let's maybe let's let it, instead of doing this, we can actually start doing this. So what happened here, and sorry for accepting the suggestion too quickly, but so what we're doing here, we're defining a function. We're defining what kind of arguments it's going to accept, so we can now pass it as an argument from another function that we're going to be, so we're calling this function here. That's how we're kind of designing this. So we have one file, one module where we are building our server functionality, and from within that server, we're going to be importing functions that we have here, and we can have functions in other places, and then calling them here to produce the results that we want. That's kind of like the pattern that we decided to apply here, just to have everything cleaner and better structured and follow best practices. So we could actually not define this. So that when this discussion about typing, and you're going to see why it's kind of useful. So we defined prompt to be a string, which you don't have to do in Python actually, because Python is a dynamically typed language. In C# you have to, But the benefits of that will be will be visible once we kind of like move this once we start kind of defining arguments in this function, which is then it's the automatically translated into the documentation. So that's kind of like the little discussion side side topic we talked about with Sergey, and you'll see it shortly. So and in addition to defining the type, I'm also assigning a default value to this prompt. And then with a tab, I am also defining, I'm here kind of like calling, I just moved the way that I called the pipeline that I defined here inside of this function. So I don't call it every time, and I can also call it every time the server runs, and I can also call it a specific moment when someone makes a request to this route. Okay, and here what I have to do, another thing that is useful that I forgot about is to define what kind of output it will generate. I have to actually remind myself about the syntax, and in order to be able to do that, we have to import a type image from Python image library, and now we can define the output. It's also useful for typing as image. We have our function here, and now we have to we don't have to, but we can just return this image. And we're gonna call this image because so like the pipe can return several images, but we're only asking for our first one. So we don't need anything else. Okay, I think this should work. Let's see. And here we need to first import it. So from ML, import generate text from image, which are already correctly guessed. And what we need here, because we specified it as we specified the default value, we technically don't have to pass an argument here, but we will just to kind of like speed up things. We're going to, but I don't want double. Wait, oh, sorry. Yeah, I don't want this to be double. Okay, I don't think it really matters, but okay, and then I can pass the prompt here. So because I defined it as a string, now you will see that in the documentation, we will see the inputs that this root takes and its types. If the server, okay, it's still loading now. Okay, it looks like it compiled correctly. See, okay, awesome. So now when you click on try it out, you can, and this is a query string. You can also define, as a body or anything, and then it will tell you what it wants, whether it's a body, whether it's a form. But we define it as a query string, and it wants a prompt, and the prompt is of type string, and it also has the default value. So now we parameterize our function and our route, so we can we can actually start passing values. So instead of, let's see if it works first, and then we can put something else in. Like, I don't know, photo of a building in a forest. Okay, it's still 15. Okay, we have another photo of an astronaut, but just so you, so you see so I can demonstrate how it's working. So let's say ultra realistic photo of a modern building in a jungle. By the way, maybe I should have said it sooner, but if anyone is more comfortable just copying the code, I mean, you can also tell me to go slower, but you can also go to the repository, the GitHub repo, and in step 1, you should have finished version of the server. So you will have a polished version of all the functions that we're going to be calling, as well as this machine learning module also ready, if you prefer to copy it from here. Okay, let's go back to, okay, so that's what we have. That's what we're getting. And the image quality is not great, but because it's only 15 steps, but it's also not bad. And this in itself is not very useful. But what's useful, and what I found useful, especially for this workshop, is actually working with ControlNet to get the images, to generate images based on the wireframe from Revit. Sergey, how are we doing with time, by the way? Should we have a little break? How are people
yeah,
doing?
So we have another, like, just over an hour.
Yeah, okay. So maybe let's kind of like expedite this server part and move to Visual Studio, because it might also take us some time there. What do you think, people? Folks who are here, do you want us to do you want me to continue and explain this in more detail, or like just show you the finished version of the server, explain it maybe, and then move on to the Revit part of things?
That sounds good to me.
Okay, awesome. Okay, so maybe we can finish that Python part, kind of an expedited version, and then take a short break, 5 minutes, water break, and then come back and do the Revit part. Does that sound good? Awesome.
That's great.
Sounds good.
Okay. So what I'm actually going to do, you can also Control-Shift-NS save everything. It's save as, sorry. Save all is Control-KS, but I can't do it because everything is saved. This is what I am going to do. I'm going to kill this. Okay. I'm going to push this, push the changes into the Git repo, just as a note to ourselves. So what I just did, I added all the changes to to my local Git repository. I created a commit. So now I can push them, and my local Git repository will be synced with this. Oh wait, sorry. With the online GitHub repo. So this is updated, and it has this whatever we coded here, this messy couple lines of code. And I did that so I can now move to step 1, to the branch check, to the branch called step 1. And I'm doing it by tapping in command get checkout step 1. And I can verify that I'm here also by looking here. So I'm at step 1, and these changes should be also reflected in my code. So when I go to main, now it's no longer, our tiny little function. It has other functions in them and routes, and so the same applies here. Let me demonstrate first how it works. I'm gonna do the same thing and run this as a server. Hopefully it will work and without any bugs. Looks like the pipeline is loading, and okay, I think I think I have another pipeline. Yes, I have simple text to image and also the control net. I'm probably going to turn it off. What I noticed that when I load two pipelines or like two models, my entire computer slows down. So I'm just going to keep it to just one pipeline at a time. But if you have a strong computer, or you can and we can talk about it a little bit later, you can also take advantage of like cloud instances, or or your company can provide virtual machines for you. You could if you have a strong computer, you can actually stack several pipelines, which would lead to better results. But let's see what we have here now. So we still have this simple text to image, but we also now have other routes that take more arguments. They're defined as all as query arguments, but also there's one that requires a file. So we can click on it and select it, and you should have this file here. So I'm going to navigate here. So this is just a screenshot from Revit, and in the second part we're going to be navigating. We're going to be taking those screenshots automatically, and we're going to be exporting images from Revit automatically and sending them to the server programmatically. So I'm going to select this one that's not inverted. So you have two routes here. One of them accepts already inverted image, like the scanny edges. Those that have canny edges, they're kind of like black and white. I mean, black background, white edges. And this one will invert it for you. The prompt has a default value of like something aerial view, a futuristic house. And it also has a negative prompt, and you can define what it should, avoid creating. I'm going to also change it to 15, not 150, and maybe specify seed. So seed, when you specify seed, you get deterministic results. So every single time you provide the same input, but also the image counts as input, you will get the same results. It's quite useful if you're, if you want to have a stable scene, or if you're kind of using it as enhancing your maybe rendering. But if you're more like experimenting, it might be you might be getting better results or more interesting if you're using a random seed. So yeah, that's also what I mean. So right now the kind of like just running, not just loading, but also running is slower. So I'm going to turn off the other pipeline in just a second, but it looks like it's working. It's just going to take a while to generate this image. So maybe as we're waiting, it shouldn't be longer than, let's say, 5 minutes. But Nathan, how's your debugging? Were you able to restart it?
I'm getting caught up to you right now. But
okay.
Yeah, I'm not sure yet.
Okay, cool. Let me know if you want to go back to troubleshooting, because we could technically now, for example. Anyone else would like to I don't know, talk about their side of things? Has anyone been able to actually, let's say, check out step 1 and run some image generation using the docs interface?
I'm having problems checking out step 1.
Checking out?
Yeah, jumping branches.
Okay, do you want to share a screen? Because we have like probably 4 minutes to have a look at it.
Here, I'll Sorry, gotta commit it.
Okay.
Okay.
Yeah.
So then,
Now if you git
Mhm.
checkout, yeah.
And is it origin?
No, it's just step 1.
Okay.
Okay, yeah. You have could type git status. Yeah. So if you want to save these changes, you will have to add them to tracking, and then you would have to commit, or you can stash them, but maybe you want to save them. So let's do git space add space dot. Oh, okay. Maybe git reset now, because I think I don't know why, but it might be tracking your like environment or like cache changes. So just git stash, type git stash, and now you should be able to check out. So arrow up several times. You can try using that. Okay.
Boring. Okay.
It's still not working actually.
That's all right. I can essentially shut down or whatever and start from here. That's not a big deal. I'm on a
Can you
virtual machine.
No, it's fine. We're still kind of waiting, and I think that's probably going to be more valuable for you than you know, everything else. So type explorer.exe space dot explorer, like a file explorer.exe without a space. Yeah,
Like
and
that?
enter. Yeah. Can you go to model server? Can you just manually delete PyCache and VNV for now? So you can select both of them and delete them. And then go back to the console and git status now again. Yeah, it was tracking VNV, but I'm not sure why. Interesting. Anyways. So now you can say, you know, go git add dot. Okay. Do you know what this is? Oh, I think you have VNV somewhere outside of the, okay. Yeah, this VNV. Okay. Can you delete it?
And there's probably one in here too.
Oh, you can leave this one because I think this one, but okay, it's fine.
Sorry.
No worries. No. I know it might be a little bit confusing. Can you type git reset again? And then git status. Okay, and now git add and git commit. Space dot, yeah, and then commit. Okay, now can you exit this? You should have either by quit or there should be.
Sorry.
Yeah, there should. It should tell you what to do. 1 second. Sergey, do you know how to quit it? It's like it's a little either D or something.
It's them, and I always use Nano for exact same reason that it's very unintuitive.
Yeah, but maybe we don't see it, but there should be like an info at the bottom of this, like where you can,
I think if you just press Q, it should quit.
yeah.
Can you
Q
try
or-
that? And enter.
Mhm.
Right, colon Q, because it's Vim. Q.
There you go.
Okay, now you can type clear. Yeah, and then do git commit, but don't hit enter. Type git commit space -m.
Okay. -m.
Space quotes, open quotes, and my progress. Type something, whatever you want. That's like the text of the comment. Your comment, my progress, and enter. Now enter. And now git status, and you should be fine. You won't be pushing it. And now you should be able to check out. So you can go git checkout.
Oh,
Yeah.
awesome.
Yeah, awesome, but now because now we deleted your VNV, so you have to actually install it again. Apologies. I wanted to help you too quickly, but so inside of the server, you would have to just the one inside of the server, you would have to install.
Okay, inside of here.
Yeah, you can do it during the break.
Yep, sounds good.
Okay, so this is what it's generating, guys. Oh, okay, wait, I have to share my screen. So now you know what we did. We clicked on try it out. We input an image, and now it generated this. So just for performance sake, I'm going to disable parts of it that are not really crucial, because we don't need to. We're just going to be using one pipeline with ControlNet. So I'm just going to comment out for now. But like if you're building it for yourself, you could have a system where you're kind of like you can control it with like some kind of more like variables where you have in separate files and you turn them off like that. But for here, I'm just going to quickly comment it out. I don't really need that either. And this will generally work faster. And I also have to, I'm just going to shut it down right now. I'm also going to have to comment it out here, otherwise I would get an error. So I'm just gonna get rid of this one and delete it from here. Okay, so just to recap this and kind of give you an overview of what we did. What we did here, we created this application that is we can talk to it or like send requests and receive responses. We created API server. We have routes that we can call and then receive responses back, and the responses that we're interested in are streamed as messages to us. So this is essentially what we built together in the first part of the workshop. We have a decorator that defines the name of the route. So it's kind of like an address that we're going to be calling. We define query parameters that we're going to be accepting, as well as file, the stream that we're going to be sending. Here, additionally, what you have a couple of like safety and clean code, or like helping us debug. If there's no file, we're throwing in errors just so we can get a response that the server was not able to process the file. Then we're reading the response, and we're turning it, we're resizing it. If it's an image that it has a white background, we're actually just converting it, and there is an algorithm. There are more sophisticated algorithms that actually could For example, if you wanted to train a data set, you would probably use this canny edge detection in order to create a data set out of, let's say, renderings of your, your office renderings or like images of buildings, and then use it maybe as, to fine tune your model. But here we know what input we're expecting from Revit. It's just a wireframe image, so we're just converting in it so we have a black background and white edges. We're resizing it just to kind of control the quality, but Stable Diffusion XL actually doesn't also accepts and outputs good results of like other formats of images. So I encourage you to read about it if you're interested in like more rectangular images. But the square ones, I actually just resized it to be a square 1024 pixels by 1024 pixels. And then I called the function that we defined here in the machine learning module. We receive a response, and if the response is successful, we return it. Technically, we could also like have some kind of check for whether the response was successful if we wanted to make it a little bit more robust. But because this is just like it's workshops, then we're not doing it here. And in machine learning module, we're defining these functions. So what we import the pipelines that we are using for image generation. We don't need this yet. We import some packages that are useful for us to define types or process images. We define here the address of the model that we're using for this pipeline, and the address comes from the model card. So for the control net generation, this is the address here. And for the Stable Diffusion XL base, this is the address here. And we save them here. And then we create pipelines using these addresses. And we move the pipeline in order to use CUDA for better and faster results. And then we define a function where we make a call to the pipeline with specific arguments that are coming from the request that an external application is making to our server. So we have a prompt, negative prompt. So the way it works, the server kind of takes care of this. It accepts these arguments. It then passes these arguments to this function, and this function is defined here. And then this function makes a call to the pipeline, and then the pipeline generates the image. We're just taking one and returning it. Maybe an additional kind of article that's worth looking into is there is specific, I think I had it open somewhere here. There's a Stable Diffusion documentation where XL is, and all its the model that we're using is and all the arguments that it's accepting is described in detail. Okay, so this is a similar kind of example card, which is also pretty useful. And on top of that, you also have source code if you want to go deeper, available here, and look at all the arguments, but you don't really have to. I mean, in order to kind of get value out of this workflow, you don't really have to go that deep. I'm just sharing this so that you can kind of like look there if you need to. Yeah, I think that will be all for this part. Do you have any questions? Do you want me to like kind of go over something or show something that's maybe not clear, simplify something? How do you feel so far?
And just to clarify, the code that we're looking at right now, this is the code from the step 1 branch.
Yes, yeah. But this code, that's the same as in step 3 branch. So like, because then now we're done with Python, and also it's the same code as we will find in step 2, step 3, and bonus. Does that make sense? Okay. So do you want to take a quick break now? 5 minutes, and then we can reconvene in 5 minutes? Okay, awesome. Let's start the timer and see you at 4:15.
Hey, Patrick, just
Yeah.
making sure that I'm caught up.
Yeah.
I need to start up the virtual environment again, activate it, and then should be good to go at that point, or do I need to use the Uvicorn command?
You have to install all the stuff.
Install? Okay.
Yeah.
Sounds good.
Okay, so you can do it kind of in the background as we're doing this. And like at the end of the workshop, even if it goes over time, I'm determined that at least one person gets the result. So I'm happy to stay over if that's okay, Sergey, or are you gonna kick us out? Okay, cool. So I'm happy to stay and like kind of debug, install the environment again, or like do whatever it takes. So because I think like like the greatest value out of this workshop will be if you have the setup and it's working and you can actually start playing around with those kind of individual components, right? Copy pasting code, or removing code, adding code, changing your UI or whatever. But I think it's less about UI, it's more about like what's happening behind. And yeah, I think that would be the greatest value out of this workshop if you could do that. Okay, I'm gonna always load it. Let's see if it's working. Yeah,
why,
yeah.
Why do we need admin privileges in order to run the code? Do you have any theories on that? Is it because it's calling an add-in in the program files directory, or trying to modify?
Right now, this one is specifically probably because it's writing. So like when you're post-built, one of the post-built commands writes to a directory that might be protected. That like the settings, your like kind of like default Windows settings protect from like programmatic access to that directory, which is C program files. And it usually is not the problem, but for this specific plugin, somehow you have to write one piece of it's another model. It's a tokenizer, and it has to be in program files Revit 2025 for the specific plugin to work. But I think anyways, that's the answer. There is maybe like a tiny caveat to it, but let's just accept it as the answer. The caveat is that you might actually not need it, depending which way. Because like the way I build it first, I build it like kind of using a different package, like a more advanced one, and then I kind of switch to a simpler one. And the simpler one, I mean, you have both. At the end, you will get a repository with both approaches, and you can explore them on your own. But like one of them, I think the one that we're going to complete in the workshop doesn't require that step, so we could actually remove it, and then you wouldn't need to. But it's just about writing, yeah.
Thanks for that.
In the step 1 branch, we have Onyx utilities instead of the CUDA utilities.
Yeah, you should have both ideally. Okay, in step 1, you mean?
Yeah.
Oh yeah, totally. That's because I think I added CUDA utilities later to the main branch. So that's why you don't have it there. I'm gonna at the end I'm gonna merge the branches, so you're gonna get one branch with like ready. So you won't have to worry about branches. Branches are just for kind of like to help you follow along. So like we complete step 1, then we complete step 2. But like after the workshop is done, I'm just gonna put it all in one main branch, and everything will be there. But just out of if you're curious, the reason it's there, it's kind of like the hierarchy of like, or like maybe the timeline of how I created the repo. So at first I created the main that was nothing in there, but then kind of like, and then I created step 1, step 2, step 3, and then I thought, oh, maybe I will add CUDA utilities just if someone wanted to verify the installation, because I noticed that some people were having difficulties, and then I only added to the main. But everything else was kind of like based on old main and it didn't have CUDA utilities, and now I added it. So yeah, anyways.
So we need to operate from within the main branch right now, though.
Say it again.
Do you want us to be in the main branch right now?
Right now, no. Right now, actually go to step 1.
Okay.
Step 1, because we don't need CUDA utilities anymore. Yeah.
Okay, gotcha.
Okay, let's jump into this, and it looks like it's working for me right now. So I'm just going to stop debugging, and let's kind of have a quick overview of what's here. Start typing, start coding, see where we can get, and then we're going to do the same thing. We're going to expedite it, have kind of like the entirety of code, explain it. And then after the workshop is done, for those who want to stay, we can, make sure that, you're getting the results that you're supposed to be getting. Okay. So right now we're in step 1. So what we have here is like, we still have this kind of skeleton Revit plugin, but model server is done. And one thing that we need to do here that I almost forgot about is, okay, I'm working in desktop. So I have here, I think I have to, I know I have to, we have to copy the model that you downloaded and unzipped. We have to copy it here inside of the CUDA not CUDA utilities, ONNX utilities. So you probably did this, you unzipped it and you have it unzipped, right? And it should be a folder. Okay, I'm going to show you how it looks in my case. Yeah, I have it here, and this is my original thing. Yeah, okay, so I'm just copying this. This is like so this is what it should have inside your folder, right? Does it have all those folders and files? Wade or Nathan? The folder that you downloaded from the drive and unzipped. You're muted, Wade, sorry.
Looks like it.
Okay, cool. Yeah, so you just move it to the location where, okay, so the location where of the workshop repo, ONX utilities, and then paste it here. Shouldn't take long. It's a big folder, but that's fine. And now we should be good to go. Okay, and now we will open the Visual Studio if you don't have it open yet. And open okay, I'm going to open it with you actually. So click on the Visual Studio 2022. It's another code editor. This is like a more full-featured development environment. It's a lot more serious than Visual Studio Code, but it's a little bit more complex, and that's why I kind of, especially for web development, I prefer Visual Studio Code, but definitely Visual Studio for Revit work. Okay, so we're going to open our project. So in the GitHub repo, go to the Revit plugin folder, then you have the plugin, open it, and we're going to start editing it. Before we jump in, I'm going to explain this structure a little bit. So the setup, technically you don't have to have 3 projects here. I'm not gonna get into detail why we have it like this, but interesting part, so the C# is a compiled language, and after, when it gets compiled, before it gets compiled, they kind of like put it in all one long document. So the organization is like more kind of like for, for humans to, structure your thinking and your code. But in addition to that, and it has a lot more kind of like levels of abstraction, and maybe the specificity of this, as opposed to what we were doing in Python, which when we were just kind of defining functions, and it has this kind of feel of where you kind of like flow and it's just like kind of flat. Here, there's a like when you think about it, and I think that will help you kind of like get into this. And I mean like switch from maybe Python and like, depending on your background, it's like really very strongly object oriented. So there's a lot of classes, and there's a lot of classes that encapsulate classes, a lot of types, and sometimes it might kind of be overwhelming, but in the long term, it is also helpful. But it's this kind of like conceptual switch from like kind of like code that kind of flows. This is more like a lot of levels of abstractions, different types, and like also don't be too overwhelmed at first. It's more of kind of like, oh, here what I have here it is what I have, the skeleton, and here it's more like what I can do with it. If you're kind of like interested in like developing a Revit plugin from scratch, Conrad had like 2 classes, as I said, during like previous AECtechs, where he kind of explains the setup really well, and also he has an in-person class where he talks about recent migration to the newer technology. Revit 25 is finally migrated to Net 8.8 core, Net Core 8.0. I mean, they don't call it core, but it's the core technology as opposed to framework. And I built it using this. So this project is built only on Net 8.0, so it won't work with previous Revit versions. But sorry. Okay. I think it's just background sounds. Anyways, so. But if you know that you want to be building for projects for Revit versions that are older than Revit, you can do this, especially with this setup that we're building out now with the Python server, because Python server is like a completely modular and like separate thing that you can build it however you want using whatever technology. And you're just making this simple technology API calls, right? Like HTTP requests to your server. So you can use, here this can look like anything you want. It could be even like, I don't know, Revit 2017, whatever, because you can still make API calls. I built it this way because the plugins, the nuggets that I'm using, I think they use Net Core as like the Net 6.0 and higher as dependency. Therefore, I'm not using framework, the Net framework, the 4.8 or 4.7 earlier versions. But it is possible, especially if you go down the path of just making API calls. But if you want to use the plugin, it won't work probably. But right now, we're going to just build out the we're going to build out the API functionality. So we're going to be kind of doing it. We're going to be kind of like doing what we just did, but in reverse. We're going to be like, what does this server want? And we're just going to kind of write a function that will send those things and expect a response. And we're going to be taking that response and like displaying it in Revit in a window that we built. So kind of like more high level and with the UI. What we're doing here, we have this external application that consists of UI, which I'm going to show you shortly. UI. So this is the UI, right? And what we want to do, what we want to be doing, we want to be able to interact with, and the way I like to do it, but it could be, as you will see it could be created in a different way, but I kind of like this kind of flexibility. So, but in order to have it, so like okay, Revit is very, so you can, so it actually will pick any active window. So you have, this is my active window. And when I click capture here, it will just capture it. So it kind of it's easier to control it if you have it square as well, because it's designed to capture square images. Kind of as I said before, This is like the easiest and you know, something that easily produces good results. So I'm using squares, but you don't have to, especially with this larger Stable Diffusion models. And when you capture it, so whatever the, you know, whatever the active window is, you click on this one, you capture it, and then you can enter your prompt. You can enter, that's the idea behind what we want to kind of create here. You have this UI, you can capture the thing. It doesn't only capture, so if you have like a rendered image here, you could actually also use it. But for this, just for the purpose of this workshop, I thought the most useful will be to use wireframes. But you could actually, the results might be even better if you have like a pre-rendered, like kind of like half decent rendering. If you put it through Stable Diffusion and like kind of like don't let it change the image a lot, it will still add a lot of details. So that could also yield good results if you want to use it as a kind of like enhancement for rendering. Anyways, so that's kind of like the setup that we have. We also created this button and panel that kind of lets us start this command in Revit. Okay, so here, I think I gotta hide this thing or move it around. All right. What we have here is, I'm going to stop here and how I'm just going to go briefly through the code and explain how it looks. So like the entry point for this application is app command. And I'm going to go briefly over this because as I said, there are kind of tutorials that explain it in far more detail. We have this entry point here. We create a panel. We add a button to this panel. And the button is defined here, as well as the method that, you know, is being executed when the button is being clicked. So we get the application, we create our model, we create our view model and our view. And this is creating this MVVM pattern. So view model. I know it sounds kind of ridiculous, but a model view model or view. So view is the UI. View model is this layer in between the model, and model interacts with, you know, let's say either database, in our case, it's Revit, and our API that we just created. View model kind of like translates whatever is being created in the model and communicates with the UI. So in this folder here, you have Stable Diffusion API, which is kind of like, you know, how we grouped it. And you have the visual representation of the UI as well as the code, the XAML code that is creating it. It's the WPF. We're using Windows Windows Presentation Framework. I think that's what it stands for. In order to build it, and it's using XAML to create those objects, which are also like classes that are built on top of .NET. So, for example, just to give a quick example, this button here it's kind of similar to, it's definitely kind of like maybe even a derivative of XML, but it's similar to HTML. It's a different kind of markup language, but you will see a lot of like similar attributes, let's say, or like horizontal alignment defined differently, but that's what it pretty much is. So you define a button, you define its parameters, you bind it to some methods, and this binding, this command creates a binding with the view model, and then the view model kind of creates a connection between this method here and the model. So, for example, generate is also defined here, and we assign ungenerate method to it, relay command, and right now we have nothing defined here. We're going to code it now, but what we want essentially, the idea is that we're going to do something here that's going to take things from the server or the API in Revit and I'm going to send some things to the Revit. So what we want to do is, get the generated object, get the captured image, send it to server, and then get the generated image back and display it in our UI, right? And so we can actually delete this throw not implemented exception. And the way we have it set up following that MVVM pattern, we will, any function that kind of like, either talks to Revit, for example, exporting view as image path, which we already have coded here, or talking to our server, which we don't have implemented yet, we will be defining here. I already defined, predefined for us the kind of like the arguments that this function is accepting, and they correspond to what the server that we created is accepting. So what we're going to do now, I can actually start the server here. So I'm just going to do this because pretty soon we're going to start generating some images here. And okay, so let's start here on this kind of like quote unquote backend. So, interacting with our little application that we just created, and start creating our method. By the way, sorry for the Western sun making my face super bright.
Also, I think there's a request in the chat to increase the font size.
Absolutely. Thanks for bringing that up. Let me do this. I'm gonna make things bigger. Okay. Okay, cool. So let's do this. I'm gonna move pretty quickly here, and also if you want to ask some questions, let's please ask. But okay, just explaining. Maybe I'm gonna start with this. I'm gonna type HTTP client and maybe explain this shortly. What we're doing here. So this is kind of like, this is again like a class that will be handling HTTP calls to our server. We're using this using statement. It's something called syntactic sugar for properly disposing of kind of like resources that we are not using anymore, in order not to clutter our application and have a good performance. It's something you don't have to worry about now, but worth kind of looking into. Yeah, might be something that's a little bit new, especially for people who are not used to working in C#. First thing that we want to define would be a query string. And let's be, so because our method actually, as you saw here, what it's expecting is a query. And this query, how it usually is, how it looks like in here, it's like whatever is after the question mark. And I'll show you maybe directly here what I mean by that. Because we're making those, calls now programmatically. So we're going to use string interpolation for this. And it already knows what I want to type in, so I'm just going to let it. I know it's because also like being kind of mindful of time, but it knows what I want and it's pretty accurate. Usually, like I would, caution not to be trustful of Copilot, but it just knows because I already defined everything here. So it's fine, and I think it should be working. And now what we're going to do, we're going to take that client that we have here that we defined, and we're going to specify base address, which in our case is localhost 800. But we're going to specify it like this. 127. Yeah, so that's our client base address. Yeah, we're gonna do this and then accept add. Okay, we might need headers. Oh, I don't want that. I'm gonna do another using I'm just going to define image stream here so we can send our image to the server by creating a new file stream and image path. And it also kind of helps you, gives you cues what it wants. Yeah, okay. And now what we need, okay, we need stream content, which will be the stream, the image that we want to send. And we will add headers, and we will also add content to the stream.
While you're typing this out, I'll just
Yeah.
quickly clarify.
Yeah, go ahead.
That there are many different ways to send information to the server using the HTTP protocol.
Yeah.
And we're just using kind of two different ways of packaging data. Like all of our prompts and parameters, they go into the query string that's part of the URL. And then we also need to kind of package the image into some type of a stream to also send it with our request. So that's
exactly
what is happening.
Probably I would, if I did it again, a more efficient way would be to have a JSON object that you're sending.
It'd probably be a post body and like base 64
yeah,
string.
Exactly. So yeah, so as you said, there are many ways, and like I think the query string, especially when when you have so many parameters, it just gets kind of difficult to work with.
Also, because you're sending like paragraphs of text, there might be like illegal characters, and you need to URL encode it, and
and then query. Yeah, I think because we're running out of time, I'm just gonna copy it here. Copy and paste it because I just wanna right now I just wanna show you the result and ideally help you get some results from this. So I'm gonna copy it from here. I'm just gonna copy the whole method to avoid bugs. Okay. Okay, I'm gonna zoom out a little bit. Okay, good. And what I also need, and I need in the view model, and that layer that communicates with the UI, I need on generate, I need to code this. So right now we have we kind of define our pseudocode here, and what we're gonna do is, so what we're capturing the image using the method that we talked about, and then we're generating the image using the method that we just wrote, copy pasted it pretty much, and that's and then we're checking whether it's whether the generated image path is null, and then we're kind of informing the user that we failed to generate if it is, just to also make it easier for ourselves to debug this, and we can now rebuild it and see whether whether we're getting any results. Rebuild. Do I have? Yeah, we have the server running. So if I didn't make any mistakes, we should be able to get some results from this. So yeah, like in C#, I don't know, with what language you're kind of most familiar, but it does look kind of like messier at first. So like writing this in Python or in JavaScript is a lot. You can kind of write it simpler and faster, and it kind of looks more compact. Here, it's pretty much doing the same thing. It just looks a little bit messy. So also don't get overwhelmed with that. It's mainly like syntax that you can just look up, and then it's not a really complicated function. As this kind of Sergey alluded, that we have two ways of like sending the HTTP request to a server, and this is just one of them. And pretty much what we want to, here it's building this creating a client and building the stream and the content, and then it's kind of like just sending it. But let's say using Fast API, this is way faster. It's way easier to kind of like put it together. Okay. Let's start this app and see whether we're getting results. Okay, we're going to type in a prompt, change it to 15, leave the other parameters as they are, and hit generate to see if anything is happening. Okay, I clicked it twice, so so it is, for example, probably here we should modify the UI to kind of let the user know that they clicked already. To avoid them from like clicking twice the way I did it, because I'm pretty sure that once this is completed, it's just going to start again. See, And so that's kind of my bad for like letting this happen. But that would be like a simple fix. And but it looks like it's working. And it's send a response, but then we're getting, okay, yeah. So because I clicked twice, I can't really save because probably I generated the same file path name. So I will have to just do it again. And so this is something that I should, as we're kind of like, this is kind of like, you know, put together pretty quickly. We wrote it in a workshop, but this should be something that should be handled more gracefully. And then, you know, a simple fix would be to like prevent the user from clicking twice on the same button in order not to re-trigger the generation.
Moment of truth.
Exactly. Okay, it worked. It's probably not what we want. So like, you know, I didn't change the prompt. So I think it generated this with maybe with like enter a prompt, which kind of like probably that's what makes it really weird. But yeah, let's try it again. Let's increase to like maybe 20. Okay, control net, I think.
Do you have to capture again, or
Sorry?
do you have to capture again, or does it?
I don't have to. I don't think so.
Okay.
But I can just because actually the capture thing is triggered. The way I designed it, it also triggers it inside. Whenever you click generate, it will first capture it.
Okay.
I'll show you in a second. And so it will work. I'm just wondering like what. Okay, yeah, I think the higher control net, the better. Yes, I'm gonna increase it to 0.8. And it should follow the lines more accurately then. But it generally also, it can sometimes, it requires then a little more inference steps to create something better. But that's like the first part, using this kind of like combined setup. So, you know, we have this server that's running in the background. We have a lot of flexibility. We have access to like Python libraries and like the latest models. See, it's kind of creating, I think, a little bit better results, right? See, it's like it followed this pretty accurately, but it doesn't really know what this is. One way of maybe having a little bit more control over this is. So yeah, those models are pretty sensitive to the input. For example, also, you know, like there's a lot of line work here that might be kind of confusing. Let's try this one. Yeah, but as I said, so this is this, okay, maybe going back to the slide deck. So that's the setup with, you know, we have this external application talking via fast API server to whatever you want, and you can add ChatGPT to it, whatever you want, in order to kind of like keep adding to take full advantage of generative AI capabilities there. I think it's the most flexible. The one that we didn't get to build together, but if you want to stay over, I'll show you quickly the setup. This kind of like approach doesn't require an external server. So in that sense, it's probably simpler, but it's less flexible to set up, and it doesn't have, the community is not as big. So even like just getting the models out of the existing models often requires a step of like downloading the models. So the thing that I asked you to download, the zipped one, downloading the model, and then like to either like translating it into an ONNX format, or looking for one that it's okay, so this is a little bit better. And now what you could do with it is you could actually because of the it takes quite a while to process this, but inside of this server, you could start adding more pipelines. So for example, this one generated like rough rendering, rough outline, right? And now you want to refine it. So and you also have examples of how to do it here with the refiner. So what you would do, you would then get another model that's called, for example, refiner, or even like run it through with the base model, but then run a refiner that would actually refine your image, the one that you generated, but it will still be one click of a button. It would, like, for the purpose of this workshop, just to keep it simple and also performing well, I didn't add it here, but it would just be like importing another, similar to what we did here before this text to image. We had a different pipeline. So we had the Stable Diffusion XL pipeline imported, a different model that we used here. And we could just take this function and add it to the one that we already have. And the results would be probably significantly better. I mean, I know because I've tried it out, but that's just one possibility. You can also add other models that are there in order to kind of keep adding and experimenting with it. Okay, maybe to kind of like pause before we jump into like this kind of like extra part of this workshop. How are you feeling? Good, or I don't know, or maybe it was too overwhelming, too complicated. What do you think?
Like I'm burning my computer down.
Yeah, that's the downside of it. Like, yeah, they're kind of heavy, but you were able to like catch up with the setup, and like now just the generation is slow, or?
Yeah, I think so. I
Okay.
just restarted my server too, so it's kind of freaking out right now too.
Yeah, totally. One way of kind of like that's not like super expensive, because like buying a new computer might be, and especially with the GPUs, it's probably, I don't know if especially if you don't want to do a lot of Stable Diffusion, or like generative AI might be not the best choice, but like SageMaker, looking into like, or like Sergey also said, GitLab, if you're just interested in like kind of like playing around with Stable Diffusion, you could, sorry, not GitLab, Google Colab. Yeah, Google Colab, or SageMaker. I mean, the SageMaker may be like the kind of like just the entry to like, it's a little bit maybe complicated. It's probably more complicated than anything we covered here, at least at first. But then you have access to this kind of like flexible pricing model and powerful tools that actually, instead of like setting up your own, a server, you could actually do it with, you could just like expose an endpoint using SageMaker. I don't know, maybe we should do another workshop on SageMaker.
My boss actually told me to look at Flux as well when I was talking to him about this masterclass.
Who did? Sorry, I didn't hear you.
My boss.
Okay. Flux?
Yeah, Yeah, he said he's using Flux to do some interesting things.
Oh, cool.
He said it's a lot lighter.
Then Stable Diffusion.
Yeah, I think so.
Okay. Yeah, also there are lighter models. The one that I picked is, and even like the version like you have a smaller version of those weights. Maybe like so maybe my mistake for picking the largest and most sophisticated model, but look around and like I think like the idea of this workshop was just to set it up and kind of like expose you to like the what's there, the most up-to-date stuff. But if you go to Hugging Face, there's a lot of models. There's a lot of articles. Oh, okay, cool. Thanks for this, Nathan.
Sure.
Yeah. Okay. So folks, how are we feeling? So like the one thing that I had on my list, and let me start sharing again. Okay, I'm going to share my entire screen. So where is it? The objectives. So the part 2 was supposed to be direct inference with ONX runtime. Kind of given that there was a lot of information here, would you rather, and we can do both. I would kind of like quickly explain the ONX runtime, what it is, and then kind of like make sure that you can get some results on your own computer. But are you even interested in like listening to like what this entire ONNX is about or no?
I'm down.
Okay, cool. So let's do this. For people who have to like log off right now and they're like, they're done with this. I mean, I hope you got some value out of it, and feel free to like message me if you have any questions about the setup or anything. It might feel at first overwhelming, but if you're interested in like doing this in Revit or even outside or separate from Revit, because with this server that we just created, you really don't need Revit, right? You kind of have like, as I said, like kind of this powerful small little tool that you can actually customize the way you want, and you can even have this like free UI with the free docs that come with Fast API. So that would be probably one way of kind of continuing exploring this, and you can actually even like write a plugin for Rhino, right? Like get the images out of Rhino and send them to the server. Actually, Sergey has like the Swiftlet, right? No, using Swiftlet, you could be sending grabs from Rhino and to the server, right? So anyways, feel free to message me if you want to talk about the setup or if you want to continue, working on this. I hope you enjoyed it and got some value out of it, and yeah, it was great meeting you all. And for those who want to stay, we're gonna do the ONX real quick, and then whoever wants, we can troubleshoot your setups in order to make sure that you can create some results. Okay, let's dive back into it. Okay, I'm going to kill both the server and this. So the good part is we don't need the server for this anymore. And I'm going to save all my changes. Let's do bonus. Okay, so this is going to be all in the main branch, but right now it's in the bonus, but that's kind of like the full package. So what we have here, in addition to this Stable Diffusion API where we're kind of like just talking to our server, we have another class that's kind of built similarly, and it's also called model. Technically, I could probably combine these two, but initially I wanted to kind of build like two separate commands, but why? Since they're kind of ended up being pretty simple. But this is this code here is like OwnNX specific, and it has like usings that are using OwnNX libraries. Maybe I'll also mention this, the NuGet package manager, which is kind of like what pip is to Python. You already have them installed, so you can just go on your own computer and explore NuGet package manager. So like the ONNX specific libraries and machine learning libraries, we have some of them here, including NumSharp and for image processing, for vectors. These are kind of like the NuGets that are available for that we're using to interact with Stable Diffusion models. They also have a really good repo. My observation, and I don't know how accurate it is, it's just like the community is not as big as Python developers, and like you have new things coming out I don't know, every week or so, or like I don't know, just a lot. And here it's maybe not the case, but this is a really good resource if you're really more familiar with C# and you want to be building that inside of Revit and not taking advantage of the kind of like the lightness and like the the community that kind of comes with Python development. So there's a lot of ready recipes that you can also copy, paste, and modify. Be careful which models you're using, because they have different input requirements, and not every single kind of like a recipe or algorithm will work with like with a XL pipeline or whatever. So for this example, I prepared the XL. Another good thing that you have here is that you have the code, the source code for the pipelines. It's already like simplified. It's not as complicated as the diffuser examples. So I also highly encourage to like look into this, what the requirements are, what are the types that they're using, and you can extend it, and build on top of it if you like. So that's the first, and like that would be like the kind of like the end of what I kind of wanted to cover in this workshop. So the difference here is that we need to have a model that's translated to ONNX, and I already have a path here, and I'm going to use it for now because I know it's working. But whatever what you have to change here is like point this method to where you copy pasted this folder that I zipped for you, and that's the only requirement here. That's another method that we're going to look at later. So, but what we're doing here, we have a method. We're using this NuGet pipeline, which is relatively, which is very simple actually to put together, similar to the Python equivalent, and it requires a model path, model type, execution provider, which we're creating here, and we want it to be CUDA. And then memory type mode. I think I was kind of trying to optimize this. And then we have the output image path where we can probably save it. And so we're saving it. We're generating the input image. That is, we take it as we take the image path as an input from our view model. I'll show you in a second. And then we define prompt options, scheduler options, and like going back to this like pipeline definition, it's good to like have, you don't have to understand everything, but kind of like to better understand those, kind of like what's happening behind, like go a little bit deeper into understanding what Stable Diffusion or diffusers do behind the scenes, because then they come up and then you kind of want to know how to set them, how to, you want to have some superficial understanding of it. And then we're just generating the image and outputting the results to our view model. So it's a really simple and straightforward way of using this. It's not as, I didn't start with this just because let's say, in order to do the control net with the model that I wanted to use, with this specific model that seems more powerful than the one that they're using here as an example, sorry. The setup, like just kind of like reading through the code and understanding the setup and putting it together requires probably like five times more time and effort than with diffusers. That's why I started with the Python development first. So that's it in a nutshell. And in the view model, you can, we can also have a look at what's happening here on generate ONNX. And we're capturing the image. We are creating this variable that will hold our generated image path. For debugging, I added this kind of like logging so I will know when it's starting, when it's finishing, and also some try-catch statements so our app doesn't crash when the generation doesn't work, and then we're exporting the image. And that's pretty much it for the simple and NuGet version of it. I'm also going to go over the complex one where you're kind of assembling your entire pipeline manually, which is definitely too complex for the purpose of this workshop, and there's a lot of code behind it, but you can have a look at it. I also I'm also providing in the repo the GitHub repository where this code is coming from. I didn't write it. This is just copy pasted here, and then there is a method that where I use the code here to assemble the pipeline and call it. So it's pretty similar again. The eventual kind of like assembly and kind of like calling it looks very similar and rather simple, but creating those components, it requires a lot more understanding and the inner workings of the models in order to be able to, let's say, swap one unit model for another, or even text encoder. But yeah, if you're really into this, I encourage you to explore this on your own. So yeah, just to reiterate, in the final version that we're going to provide to you after this workshop is done. So like, I'm just going to merge all the changes and flatten this repository. So like everything you want will be in the main branch, and you will have the Revit plugin. You will have pretty much context of this bonus session here, including this little console app that I used when I was building custom pipelines. It's actually useful to not to be forced to start Revit every single time. So whenever I build something that's more complex and requires a little time, and I can test it beforehand using a console app, I do it, and that's what I did here. So you will also be able to kind of like run inference in your console, but just for testing. So it doesn't really have UI or anything. Yeah, that's it from me. And now, if you want, we can jump into debugging, unless you have any questions or comments or complaints.
Well, I hit a timeout, so that's where I'm at.
Okay.
I was generating the image, yeah, just timed out.
Oh no, yeah, that's so. What's your like GPU? Do you know?
It's RTX 3000. It's old.
Yeah.
So yeah, that might not only be about the GPU, but also the HTTP web requests have a default timeout, which I think is like 30 seconds or something.
Mm-hmm.
So if you're not hitting that time frame, your request might time out. what I would recommend at this point, and this might make things a little bit more complicated, but if you want to run long jobs, you might want to consider switching to like a WebSocket, right? So that you're not expecting the response in the same request. You're just kind of like sending it out into the void and just waiting until something comes back.
Yeah. Something I haven't tried with like long. I actually tried it, but like they were not taking that long. So Fast API also has something called background tasks. It's kind of like so they don't recommend using this for anything like heavier or more sophisticated, but I'm going to paste it here because what it does, Sergey, it's kind of like it works as a kind of like queue, you know, like kind of async thing. So pretty much it's like it queues that task, but it immediately frees the server. So you can kind of ping the server and like you get the response, but the task is being kind of completed. I honestly don't think maybe it's the right way for this kind of job, but because you kind of want to know what's happening behind there, and this is kind of like a quick fix. And usually what he suggests, the author of Fast API, just for like sending an email or like maybe API calls that are a little bit longer than normally, right? So for something like that, either like a WebSocket or like a custom queue management system would, but you don't want to probably get into that because it's just not that simple. But anyways, what you might also try doing a quick dirty fix, which will affect the quality of your images. Do you know? I'm going to show it quick. The function that actually formats the image, you could change it and restart the server. I'm going to share quickly, because that also affects the speed significantly. 1 sec. Here, the crop and resize image. So it takes as an optional input a tuple of 2 numbers, and that's how it resizes it. So in whichever function you're calling, whether it's maybe let's assume that you're doing this invert, you can actually here pass another input. Let's say, is it 512, like the standard ML size, or is it something else? I think it's 512.
It's 512.
Yeah. So you can pass this, and this should improve the speed probably. Also, I'm not sure if did you comment this out?
I don't think. Well, I took the code from step 1. That's what I'm running right now. So.
Okay, so but I'm not sure if it's kind of, I'm not sure whether it is, but it might be. But double check it. So you could do this, and depending on your computer, there is like this. You could try doing offloading it to CPU, but I didn't have great success with this because I think maybe the newer Torch already does it or something. What do you think, Sergey, about this? Because this might help. I don't know. So you might try adding this line, but it didn't really help me. But if you do those 2 things, like if you have this commented out and you scale it back to 512 by 512, you might have better performance. But worse image quality. And this XL is what they say, like and actually I think the lowest resolution is like 700 something. I don't remember what the number is, but below that the quality deteriorates significantly. But there are other models that are, yeah. Thank you, Haley.
See ya. Also, I think that just to get it to work with the current setup, I think you can actually set timeout manually on an HTTP request.
Yeah.
So you can just extend it.
I have to look that up. I don't remember how to do it in Fast API.
Yeah, and obviously it has to be server side.
Yeah.